Hello friends, welcome to Chemistry Simplified. In this video, we are going to solve chemical equilibrium questions from the previous CSIR net examination. So let's get started. They have given us an equilibrium and they have asked us to calculate the equilibrium constant in terms of pressure. So step 1 is to write the formula for Kp. That is Kp is given by partial pressure of C power 2 divided by partial pressure of A power 2 into partial pressure of B power 3. So to know what is the partial pressure of each of the gases involved, we have to calculate the ice table from which we can calculate that. So we are drawing the ice table, in this case like ICE, and the components involved are A, B and C. So what happened is that we know that we start with 2 moles of A and 2 moles of B, and there is no moles of C. At the time t, 2x moles of A has been reacted, whereas in case of B it is 3x mole has been involved, whereas 2x moles of C is being formed. So the concentration in terms of number of moles of A is given by 2 minus 2x. This should be 2 minus 3x. This should be 2x. And this concentration they have given in the question that it is 0.8, and this is equal to 0.8. So we can calculate x from that. So x is equal to 0.4. So once you know what is x, you can calculate the number of moles of A and B at equilibrium. So this is, if you calculate it, it should be like 2 minus 0.8, it is 1.2, this should be 0.8. So now we have calculated the number of moles of each of the reactant and the product at equilibrium. So now you have to convert these moles into the partial pressure. So the relationship between, to calculate the same, we have to convert these moles into mole fraction. So we are calculating the mole fraction. It is given by XA is given by 1.2 divided by 2.8. That is roughly 0.43. So likewise we have to calculate it for XB. It's going to be 0.8 divided by 2.8, and it is 0.285. And it should be the same in case of XE, that should be 0.285. So now we have calculated the mole fraction, and the relationship between the mole fraction and the partial pressure is given by, so XA is nothing but NA, that is number of moles of A, divided by NT, that is the total number of moles. In other words, we can write it as the partial pressure of A divided by the total pressure. So we are just rearranging it for PA PA is equal to XA is 0.43 moles into the total pressure at equilibrium is given in the question, that is 2.0 bar. This is equal to 0.86 bar. The next one, PB is equal to 0.285 into 2, that is 0.57 bar. So now we can calculate for PC, that should be similar to that of PB, that is 0.57 bar. So now we have calculated the partial pressure. We are going to put it into the formula of Kp. So therefore Kp is equal to 0.57 squared divided by 0.86 squared into 0.57 cube. So the value of Kp is obtained to be 2.38. The rounded off value. So now this value is approximately close to 2.4. So I repeat once again. Step 1, we have wrote the equilibrium constant in terms of pressure using the partial pressure of the reactants and the products. Then to find out the partial pressure, we draw the ice table for the reactants and the products, and from that one we have calculated the value of X, and by the way we have calculated the concentration of A and B at equilibrium. Then we converted them into the mole fraction. From the mole fraction we converted that into the partial pressure, substituted in the value of Kp formula. Then we have calculated the answer. So we'll see one more question from chemical equilibrium. This is the next question from chemical equilibrium. It is asking us to find out the rate of the reaction, or in terms of d NO2 dt, that is how it is. So for this one, step 1 is to write the rate of the reaction. So you are going to write the rate of the reaction. The rate is given by 1 by 2 d NO2 divided by dt, that is given by K2 N2O2 into. So this is the rate expression for the given equation. So what we are going to do is that we have to calculate what is the concentration of N2O2, because it's a short-lived intermediate that is formed in step 1 and disintegrating the reverse of step 1 and also in step 2. So we are trying to apply the steady state approximation. Abbreviated as SSA. Steady state approximation on N2O2. So from the equilibrium you can find out that N2O2 is formed in K1 NO squared, and disintegrating the reverse of the step 1, that is K minus 1 of N2O2 plus K2 N2O2 into O2. So we are just rearranging this expression to calculate N2O2, that is given by K1 NO squared divided by K minus 1 plus K2 O2. They are mentioned in the question that the concentration of O2 is high. So therefore what will happen is that this value will be very big compared to that of this. So that means like it's very high. So they have K2 O2 going to be very high than K minus 1. So this value can be neglected. So therefore your concentration of N2O2 given by K1 NO squared divided by K2 O2. So we got the expression. Now we are going to substitute this into the rate one. So that could be like half a times dNO2 dt is equal to K2 O2 into K1 NO squared divided by K2 O2. So this and this will get cancelled, and we are trying to push this 2 to the other side, so this will become d of NO2 by dt is equal to 2 times of K1 NO squared. So we know the answer now. This is the right answer. So what we did is we write the rate expression for the step 2, then we went on applying the steady state approximation on the short-lived intermediate. In this case it is N2O2. Then we calculated the concentration of N2O2 using the steady state approximation. In the question they have mentioned the condition that the oxygen concentration is high, so we applied it. So you could see that this value becomes insignificant, so that will give you a new N2O2 concentration. Then we substituted into the expression and get the answer. So I would encourage most of us think physical chemistry is very difficult to cope up. Remembering formulas is very difficult, but in reality you get mostly easy and direct questions from physical chemistry, especially from kinetics, equilibrium, catalysis, and thermodynamics, and also from adsorption and so on. So I encourage you to always have a good understanding with physical, and you have to choose one more branch, that is on your own wish. I hope you understand how simple physical chemistry to score good marks in the CSIR. Thank you so much.